Hello everyone. This video here is going to focus on just a basic introduction to trigonometry. We'll simply define the three big trigonometric ratios and show how it's applied with separate problems. In the end, also we'll talk about why we have these ratios and why they work. Let's first just define all the different trig ratios, and I guess the basic way to do that is just to start off with a triangle. Here's a basic triangle. One side is labeled X, one's Y, and the other's R. And if you're curious about why I chose these letters, X is horizontal, Y is vertical when you graph. R is like the radius of a circle, and I'm not really going to explore that in this video, but just know that this kind of stuff does involve circles. What you'll want to do with this, what you first want to understand is that this is always with respect to an angle, an acute angle. This is for right triangles only, and we normally don't refer to the right angle in this. So with respect to an acute angle, whether it's this one here that I'm pointing at, or the one up top, you can derive all the different sides. That really should be your main focus. Which side is the hypotenuse? Well, the hypotenuse is always the largest side, and the right angle is typically pointing at it, so if you notice that it's doing that essentially. So this side here is your hypotenuse, and I'll just abbreviate it as HYP. This angle in question, and if you're wondering what this is, that's a Greek letter, theta. If you draw an arrow out from theta, what you'll find is that this side is opposite. This makes this third side here adjacent. Now, just so you know, the word adjacent means next to. So what you're looking for really is just the side that is next to the angle. And if you're thinking, well, isn't the hypotenuse also adjacent to it? Yes, it is, but understand that opposite and adjacent are with respect to the two legs. So which leg is opposite and which leg is adjacent? The hypotenuse is just the largest side. It is not a leg. So what are the three trigonometric ratios? Well, they are the sine, the cosine, and the tangent. And these are the definitions for their ratios. The sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. The tangent is the opposite over the adjacent. Many people will often abbreviate this as SOHCAHTOA. And this is a phrase that you might want to consider committing to memory. The sine, that's the S here, is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. So a lot of times people will just simply say SOHCAHTOA, SOHCAHTOA. This is kind of a method which people will use to help memorize these three ratios. Let's do an example here. Let's say that we need to determine the tangent of A and the tangent of B. Let's first worry about angle A here. With respect to angle A, determining the tangent, let's first identify our side. Determining the sides, in other words, which one's the hypotenuse, which one's opposite, and which one's adjacent, should be your first consideration. And remember, it's always with respect to the angle in question. So if you're trying to determine, say, the tangent of A, well, you're talking about angle A. So the hypotenuse is always going to be the largest side, regardless of what angle you're talking about. But as far as the opposite and adjacent sides are concerned, from angle A, if you draw an arrow out, you determine the opposite side. That leaves the other side is the adjacent side, the side that is next to angle A. So what is the tangent of A? Well, according to this, the tangent is opposite over adjacent. The opposite side is 4, and the adjacent side is 8. So since it's this side over this side, it's going to be 4 over 8. Which simply reduces to 1/2. And that's essentially it. Now let's turn our attention to the tangent of B. Since we're talking about a different angle here, we kind of have to start over in that we need to identify our sides. Again, the hypotenuse doesn't change, but since we're talking about angle B and you draw an arrow out, you hit the 8 side here. This side instead is opposite, so that makes the 4 adjacent. So you see that these two switch places. What that means essentially is that if you want to determine the tangent of the other angle, that's simply the reciprocal for the tangent of the first angle. The opposite side is 8 this time. Therefore, that goes on top and 4 on the bottom. So when you reduce that, you don't get 1/2 this time. Instead, you get 2. And that's it for this one. Let's try another. Let's determine the tangent of this angle, and that's a Greek letter alpha, and of this angle, that's a Greek letter beta. So the cosine of beta, the tangent of alpha. Just as before, let's identify our sides. Let's get the tangent of alpha first, so that way we know which angle we mean. With respect to angle alpha, this side is opposite. The 5 is the hypotenuse, and the adjacent side, therefore, is it's got to be 3. Recall that the tangent, that's right here, SOHCAHTOA, the tangent is opposite over adjacent, which means if we determine the tangent of alpha, we don't know what goes on top. We just know that 3 is on the bottom. So let's try and figure out what that other side is supposed to be. And how about we label it x? Now you may recall that since this is a right triangle, if you have two sides and you want to determine the third side, you can use the Pythagorean theorem. And that's what we'll do here. Since the hypotenuse is the largest side, 5 goes at the end. And if you solve for x, you should get 4. So let's go ahead and put that in. Now that we have the opposite side, we can finish this off. And there's our solution. How about the cosine of beta? Well, for beta, we need to again start over. So identify the sides first. The hypotenuse never changes, so it's still 5. If you draw an arrow out here, we get the opposite side being 3. That makes the adjacent side 4. So you'll notice that whenever you switch angles, the opposite and adjacent side switch places. Now for the cosine. Well, the cosine is supposed to be right here. That's why we have SOHCAHTOA. Adjacent over hypotenuse. The adjacent side here is 4. The hypotenuse is 5. So therefore, 4/5. By the way, I want to note that the hypotenuse is always the largest side, and because of that, the cosine is never going to have a fraction that's bigger than 1. Same holds true for the sine, because it too has the hypotenuse as a denominator. The tangent, on the other hand, you'll notice we have a fraction that is bigger than 1. The tangent can have an answer that is less than 1 or more than 1. It's immaterial. But for the sine and the cosine, you'll never get a fraction bigger than 1. Okay, let's try another. In this case, we're going to solve for x, knowing only one side, and we have an angle. We're going to use the same process, but the way we do this is going to be slightly different. Let's again identify our sides, and if you're wondering, well, with what angle? 57 degrees. So with respect to 57 degrees, this side is opposite. That makes the 8 adjacent. Now, that means this side is the hypotenuse, but I'm not really preoccupied with that. I'm just simply concerned about what we have right now. So here's the deal. You have the opposite side. You have the adjacent side. Now we're going to use this, SOHCAHTOA, to help us determine how to set up the problem. You must think, between the sine, the cosine, and the tangent, which of these three sports the opposite and adjacent sides together? You would be right if you guessed tangent. The tangent is the opposite over the adjacent. So what you're going to do is you're going to write tangent. And since the angle is 57 degrees, it would be the tangent of 57 degrees. And the tangent is opposite over adjacent, so that's x over 8. From here you have two ways to proceed. What you can do right here is you can just take this 8 here, and since we have a fraction, you can just simply multiply out 8 from both sides, left and right. And what that does is that eliminates this denominator. And then let your calculator do this calculation here, and then just round to the nearest tenth. And that would be it. What others will do is they'll determine the tangent of 57 right now. And before I continue, I probably should have said something about how to determine the tangent of 57. You can do this in one of two ways. You can look it up in a chart. If you have a chart like this, what you would do simply is just simply scan for the angle, and then align that for the column and the tangent, 1.5399, and then just use that, writing it in place of the tangent of 57 degrees equals to x over 8. The other way would be to type this into a calculator. Here's an example of one, and what you would do is you would simply enter in, just pressing the ordinary tangent button like you're seeing here. For some calculators, you have to press the angle first, so you have to go 5, 7, and then tangent. For others, you can press the tangent and then 57. It all depends. How do you know which one your calculator is? Pretty simple, really. If you have to press the equal sign to make your calculator do anything, then you press tangent first. If, on the other hand, it does calculations as you go, you can type 57 and press tangent, and then it'll give you the calculation immediately. From here, you can multiply both sides by 8, or you might want to think of it this way instead. Put a 1 under here and cross multiply. That would also give you the same result. In any case, 12.3 works as an answer. How about we do another? Solve for x. We're going to go through the same process in that you want to identify your sides. With respect to 26 degrees, this side's opposite, so we have nothing there. This one's adjacent, because this is the leg that is next to the angle, and this is the hypotenuse. Recall that the right angle is always pointing right at the hypotenuse. So now, SOHCAHTOA, this is telling us how to set up the problem. We have the adjacent side. We have the hypotenuse. Which of these three here utilizes the adjacent and the hypotenuse? Is it the sine, the cosine, or the tangent? Hopefully by now you've made the distinction. It's the cosine. The cosine is adjacent over hypotenuse. Therefore, you write the cosine of the angle, which is 26 degrees, is equal to the opposite side, which is 18, over x, which is the hypotenuse. And now we're ready to solve this. Just as before, you could work this out without calculating first. And in doing so, that would leave us with x times the cosine of 26 degrees is equal to 18. And then from there, since you want to isolate x, just simply divide out the cosine of 26 like this. Your calculator does the rest of the work in that you will type in 18 divided by the cosine of 26 degrees. And you get 20.0, and I'm putting 0.0 to emphasize that we rounded off to the nearest tenth. Alternately, we just determine the cosine of 26 degrees right here, again using either the chart, and this is a little tough to see, but 26 degrees here, cosine's right here, and you'd write this value. Or you would just simply tap it into your calculator. Your calculator will give you quite a few decimal places, but typically 4 decimal places is a good amount to go out to. Place a 1 underneath here and cross multiply. And then to finish this off, you'll want to divide this out. Either way, you still get the same answer, and that's really all there is to it. All right, let's do one more. Determine the angle this time. We're going to use the same exact process as before. Identify your different sides. 12 is opposite. How do we know? Because right here is the angle, and arrow out hits the opposite side. That makes the 20 the hypotenuse since the right angle is pointing right at it. Just as before, opposite, hypotenuse, we want to use SOHCAHTOA here to tell us what to do. The opposite and the hypotenuse side is used for the sine. So we're going to use the sine to help figure out the angle. Therefore, we write the sine of alpha equals the opposite side, which is 12, over the hypotenuse, which is 20. Now from here we have two different ways of going about this. If you have a chart, what you can do is you can take this and you convert this to decimal, and you would do that by taking 12 and divided by 20. This is the thing to do if your calculator is not a scientific calculator, or if you're without a calculator at all. You would just simply divide this through. So 12 divided by 20 gives us 0.6. What you would do then is you would look up 0.6 in a chart. So here's my chart, and since we're talking about the sine, you're going to be paying attention only to the sine columns. In the sine columns, you'll want to look for where it says 0.6. Now, if you don't find 0.6, then what you do is you find the ones closest to it. On mine, 0.6 is pretty close to here. Again, my chart's a little tough to see, but we trace back to here, 37 degrees. 37 degrees is what the answer is, and that would be your answer for alpha. The alternate way is if you have a scientific calculator. In a scientific calculator, you're going to have to calculate what is called the arc sine. To access this, you're going to need the sine button, but if you look right above it, and this is for almost all calculators that have a scientific, that have the sine, cosine, and tangent, right above the sine you should see it says a little sine minus 1 right there. Well, that's what you want to access here. So what you do is you press your shift button, then the sine button, or it'll say second, meaning the second function right above. These things are color coded, so like you'll notice this is kind of an orangish type color on mine. All the orange letters, text, matches with this button here. So take the arc sine of this value, and what it'll spit out is a very long number. Mine spit out 36.86989, etc., etc., etc. It's a very, very long number. You're to simply round this to the nearest degree, though, so 37 degrees is good enough for us. Please keep in mind that in order for this to work, you have to be in degree mode. A lot of calculators, they have different kinds of modes, and the most predominant ones are the degree mode and rad or radian mode. So you want to make sure that you see this little thing here in your window, DEG. If you see that in your window, then you know you are in the correct mode. If not, you want to press your mode button to do that, or look for the DRG button. This button is also on a whole lot of calculators, and this allows you to go between degrees, that's the D, to radians, which is the R, and then gradient, which is G. These are all different ways of calculating angles, and degrees is just one measurement, and it is the most common measurement, especially when it comes to triangles. Okay, so why does this trig stuff works? Well, it all works because of similar triangles. All right triangles have a 90-degree angle. So if you have a second angle that you know, like say here and here, 30 degrees and 30 degrees, well, these triangles are similar because of angle-angle. Because of that, we know that all the sides are in proportion. Basically, what that means is this. That means that we know that the 1 is going to match with the 4, and that should equal to the 2 over the 8. We can also rearrange this a bit differently. We could, for example, match, say, this side, the 1, versus the 2, the opposite side versus the hypotenuse, as you're seeing here. That should be an equal ratio to, for this triangle, the opposite side being 4, and the hypotenuse being 8. They're all in proportion. Notice that 4/8 is the same thing as 1/2. 1/2 is 0.5. If you were to determine, since this is opposite and hypotenuse that I'm using, if you were to determine the sine in your calculator would come up to 0.5, which, by the way, is what we have here. And no matter how big the triangles are, those sides are always in proportion because the scale factor remains constant. And that's why this trig stuff works. That's it for this one. I'll see you next time.